Okay, here's where we begin to dive into some concepts that I think will really help your understanding. But I want to tell you up front, there are only two things from this video that you need to know, and that's the Pythagorean theorem and the distance formula. And at the very least, if you don't understand anything else that I say, you could at least memorize these two things. You can memorize the Pythagorean theorem so that you can use it every time, and you can use the distance formula. But what I'm also going to do is I'm also going to try and show you how those two things are connected, how the Pythagorean theorem actually connects to the distance formula. And the truth is, I'm going to tell you up front what I'm going to show you. What I'm going to show you is that the distance formula actually comes from the Pythagorean theorem. But if you don't understand the connection, or if you feel a little fuzzy about how those two are connected, that is okay. All right? It is okay for you to not 100% perfectly understand the connection between the two. All you need to know, and all you'll be tested on, is the Pythagorean theorem and the distance formula separately. But what I think will happen is if you can begin to understand how these two things are connected, it will help your understanding of both. Okay? So that's what we're going to try to do here today. So let's jump into it. Okay. The Pythagorean theorem says this. This is the first theorem of the year. Maybe in class we will prove it so that you can see actually where it comes from. But the Pythagorean theorem just says this. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. That's a lot of words. What does that mean? Well, it means this. Let's say I called the lengths of the legs. Well, in a triangle, we call the shorter sides legs. So this is a leg, and that is a leg. That's called a leg, and that's called a leg. And this side, the longest side of a right triangle, we call the hypotenuse. Okay? And so let's say I called this leg A, this leg B, and this leg C. Then the sum of the lengths of the legs, well, the length of this leg we're denoting by A. So the sum of the squares of the lengths of the leg. So I'm squaring the length of the leg, which is A squared and B squared. And let's talk about the sum, so we're adding them together. The sum of the squares of the lengths of the leg is equal to the square of the length of the hypotenuse. Well, what's the length of the hypotenuse? We're calling that C. So this is A squared plus B squared equals C squared. So that's the Pythagorean theorem in short. Now, what if we called this point A, capital A, this point B, and this point C, okay? Like they were their own segments. So look at this. AB is a segment, AC is a segment, and BC is a segment. So how would I write this same thing in terms of, if I write them in terms of their segments instead of just referring to the entire side as A, B, and C? If I use just segments, how would I rewrite the Pythagorean theorem? What I want you to do is I want you to pause the video and try to do that on your own in your notes really quickly. Okay, so hopefully you've tried this on your own. And what it would look like is little a would be referred to as the segment AB. So it would look like this, AB squared. The distance between points A and B squared plus the distance between points A and C squared equals the distance between points B and C squared. Okay, so it's the same thing, just another way to write it. Why did I write it this way? Well, for a couple of reasons, and it's going to get to our understanding of what the Pythagorean theorem is. Let's say I had this exact same triangle, but it was on it was graphed in an XY axis. So let's say I had this here, okay, and it was a right triangle, and so this would be a 90-degree angle. But let's say, so we know the coordinates. How would I find the distance between, let's say, these two coordinates right here? Let's say I named all of these coordinates. Let's say I named this one like we just did. I named that one A, I named that one B, and I named this one C. Let's say I wanted to find the distance. Let's say I wanted to find AC. Okay. How would you do that? Well, like we learned in the last lesson, AC would just be the difference between the furthest x-coordinate to the right and the next x-coordinate, right? So it would be, if these 2 points were on a number line, if this was a number line instead right here, then this would be x2, this would be x1, okay? I'm just showing you that, and then I'm going to take it away. And we would just subtract the x value of this coordinate from the x value of that coordinate, okay? So once again, I'm going to take both of those away. And so we could actually do that, right? And we would find that AC here is, the x-coordinate here would be 5, and the x-coordinate here would be 1. So AC is 5 minus 1, and it would be 4, okay? But in general, what we would know is that how to find this. Let's say I didn't have, if it was just this graph, but I didn't know the numbers. What we would say is that the distance AC is x2 minus x1. Okay, so let's say that's x2 minus x1. All right. What about the distance between A and B? Well, now it's not on a horizontal number line. The distance between A and B is on a vertical number line, right? And the vertical number line we, of course, refer to as the y-axis. How would I find the difference between these two? Well, you'd find it the same way. Instead of using x2 minus x1, instead I would use y2 minus y1. Okay? So here we could actually figure out what that is. Y2 here would be 3. The y value of this point is 3. And here the y value of this point is negative 2. So 3 minus negative 2, taking the absolute value, and clearly, oh, forgot a parenthesis. Clearly that equals 5. So the distance between those 2 points is 5. But in general, the distance here between points A and B would be y2 minus y1. Okay? But now, what about the distance between B and C? That one's a little bit more complicated. Why? Because it doesn't just involve moving in the x direction and the y direction. It's a diagonal line. So I can't just subtract one thing from another because I'm moving both across and down to get from B to C. From A to C, I'm just moving in the x direction. I'm just moving horizontally. And to get from A to B, I'm just moving vertically in the y direction. So it's a little bit more complicated. But according to the Pythagorean theorem, we know that something is true. We know that the square of the lengths of the legs is equal to the square of the length of the hypotenuse, right? We know that from our last slide, I'll write it right here, AB squared plus BC squared, I'm sorry, that's AB squared plus AC squared equals BC squared. That is just by definition the Pythagorean theorem. And if I knew these values, I could plug in and find that. And we know that AC is 4 and AB is 5, so we could actually plug those in and find what BC is if we wanted to. But in general, what we know is true is if instead of, so let's actually do that. If we plugged in 5 squared is 25, 4 squared is 16, so AB, if AB is 5, 5 squared is 25. AC, if AC is 4, 4 squared is 16. That would equal BC squared. 25 plus 16 is 41. And we're not quite done. In order to find BC, we would need to take the square root of both sides. So I'm going to squeeze it in right here. BC would equal the square root of 41. And 41 is a prime number, so it can't be simplified. Okay? But in general, what do we know is true? In general, what if we didn't know these values? What if we didn't know that AC was 4 and didn't know that AB was 5? We could replace AC and AB in this formula right here with x2 minus x1 and y2 minus y1. So I'm going to do exactly that. So in place of AB, I'm going to write y2 minus y1. And I'm going to write it in parentheses. So if I plug in y2 minus y1 for AB, that's y2 minus y1 squared plus x2 minus x1 squared, because remember, AC, right here, we have AC squared. AC here is the same as x2 minus x1, so I just replaced AC with x2 minus x1 squared equals BC squared. And guess what? If I take the square root of both sides, and take this square root and this square root, what do I get? I get the distance formula, right? Over here, this would just become BC. And over here, I would get the distance formula. So you can see, hopefully, what I hope this showed you is that this formula, which is the distance formula, is actually just another way of rewriting the Pythagorean theorem. It's just how it's the exact same thing as the Pythagorean theorem if I solved for finding the hypotenuse on an xy axis. Okay? So if you didn't learn anything about this, or you felt kind of lost, what you can remember is that the Pythagorean theorem and the distance formula are actually the same thing written two different ways. So officially, the distance formula looks like this. In general, the distance between 2 points AB is going to be the same thing as the square root of x2 minus x1 squared plus y2 minus y1 squared, which is what we just solved for right here. If you see this, that's the exact same thing. Y2 minus y1 squared plus x2 minus x1 squared, and the square root of all of that. So that's the distance formula. So these two are our x and y coordinates, right? X1 comma y1 is an xy coordinate, and x2 comma y2 is an xy coordinate. So if all I knew were their coordinates, I could still use the distance formula. Here's what I mean. Here are 2 points, and here's the question. Given K, L, and M and their xy coordinates, so here's an xy coordinate, here's an xy coordinate, and here's an xy coordinate. Are LM and KM the same length? It's asking us if they have the same length. Well, we need to use the distance formula to do that. So I'm going to find just first the distance between K and L, and then what I want you to do when I'm done is find the distance on your own between L and M. KL equals the square root of x2 minus x1. Well, the second x coordinate is L, is for L, so that's -2, minus x1, which is the x coordinate for the first point, which is also -2. So -2 minus -2 squared, all of that squared, plus y2, the y coordinate of the second point, which once again is L, so y2 is 3, minus y1, the y coordinate for the first point, which is K, so 3 minus -2 squared, and then I need to take the square root of all of that. So let's continue this work here. -2 plus, subtracting a negative is the same as plus, so this becomes -2 plus 2 is just 0. So this becomes, this whole thing over here just becomes 0 squared. Plus 3 minus -2, once again, we're subtracting a negative number, so that just becomes plus 0 squared plus 3 plus 2 is 5, 5 squared. Okay, so overall, if I simplify this, I have 0 plus 20 plus 5 squared. 0 squared is 0. 5 squared is 25. So 0 plus 25 is square root of 25, which is 5. So what are we doing here? Remember, this is KL. So the distance between points K and L, we would say, is 5. What I want you to do is I want you to do the same thing between points L and M and between points K and M on your own. Try those on your own, and then we will talk about them in class.